to what we call the naive, the intuitive meaning. They're not the same. You need both. One for making arguments valid, because how do you know? In other words, you said you own a house. What proof have you got? You take out a contract and say, I mean, lo and behold, right? On the other hand, you walk around with your contract in your pocket? No, you don't. You don't need to. What you need to is to know exactly what it means you own a house. Therefore, you can paint it without asking people's permission, like that kind of thing. So that's, you will have to have a gut feeling for what you have defined, so that you can think about it this way. You need both. So that's part of learning methodology. Any more questions? Yeah?
Try to make a statement.
Yes.
I really like how, I realized this as you were doing the division algorithm, and I've never done this before, and I always do the same thing as Amy done, where you skip. 2 doesn't go into 1. Okay, let's move on. But yesterday we were doing that, and I really like how, and this illustrates this point, I really like how you say 2 doesn't go into 1, so we put a 0.
That's exactly what I did.
Yeah.
And you move on, and you go along, and you bring it down.
Yes. Exactly. Yes.
And I really like that because I realize not doing long division that often, when I've gotten to the point of 2 goes into 0, there's sometimes where I'm like, it doesn't go into 0, okay, let's just move on.
Yeah.
But I really like how the redundancy of doing it at the beginning and then remind me, because at the end that keeps me uniform throughout. So that I also have to put that 0 there because 2 doesn't not go into 0, so I have to put a 0. And I really, that just was hit home with me when I saw that here, because sometimes I'd just be like, oh, 2 doesn't go into 0. Okay, let's go. And you forget to put that. Yes.
You know, you're bringing out a very important point. I was trying to explain to you what an algorithm is. And I tried to tell you, for example, the algorithm does not respect place value. Okay? Well, I didn't quite say it right, but I think Aaron said it right. An algorithm is, I said, well, I did say it, but not well. I said it's an objective statement of steps that you have to take. If the steps depends on the kind of number you have, I react one way. The kind of number you have another situation, I have to react another way. Is that what you call a step-by-step description? No. It is a uniform description that you do regardless of what the numbers are. And that's why on purpose I chose to tell you, you don't ignore this. This idea about the fact that I said go in, then I skip. You don't skip nothing. So you want in here, you say, well, now you have to, when you do an algorithm, you have to think of yourself as a machine. Right? Like in here. 2. A machine looks at this, you say, you're dividing a number by another number. You have instructed the machine what to do. What does it do? Well, it's 0 times 2. You get 1 remainder. The machine says, when you see a remainder, multiply by 10 and add to the next digit. 18. And now you say it's 9, 18, 0. Machine says when you see a 0, see n number, that's the remainder, multiply by 2 and add to the next number. Good. 2 times 0 is 0. Pull down is add to 0 is 0. Fine, not a problem. Then what do? You have a number 0, you have number 2. What quotient what remainder you get? Well, exactly what you get. This complete uniform. That's what Aaron is saying. Thank you.